Okay, in last class we have seen how to generate a CFG for given a language. I think we have discussed about 8 different examples. Uh, Now there are few doubts in from I think from fifth example there are few doubts for few students. Uh, I'm going to revise those things. Then we'll go for the next concept. Now the fifth one, the given language is this one, a raised to m, b raised to n, where m should be greater than n and n should be greater than or equal to 0. Means here you need to generate m number of a's and n number of b's, and number of a's should be greater than number of b's. This is the given language. Means in every string generated in this language, number of A's should be greater than number of B's. Now to generate this language, we are going to take a help of the first language, the this one, A raised to n, B raised to n. Here also we are going to have n number of A's and n number of B's. Now only thing, we need to add some additional A's in this grammar so that it is going to satisfy with this particular language. Here we are going to have n number of a's and n number of b's, and after that we are going to add some additional a's to this language so that it satisfies the particular language. Now the string supported by this language, the minimum string which is supported by this language is, take a value for n as 0. Means 0 number of b's means it is not going to contain any b, and a should be, number of a should be greater than this b. Means you can have any number of a's for 0 b's. You can have 1 a, you can have 2 a's, you can have 3 a's, 4 a's, 5 a's with 0 b's, because number of a's should be greater than number of b's. Okay, now let us take the first language help. In this we have created n number of a's and n number of b's by using this grammar. S tends to a s b slash epsilon. Now this is a grammar which generates strings which consist of same number of a's and same number of b's. Now let us take this as a sub part of this grammar. S1 is equals to a s1 b. Here we have taken as s1 because it is the sub part of this particular grammar. This is not a complete grammar, hence we have taken here s1. S1 stands to a s1 b slash epsilon. This is a grammar which generates n number of a's and n number of b's. Now how to satisfy this condition? If you should have more number of a's compared to number of b's, you just try to add some more a's. If you add some more a's, then number of a's are going to be increased, then your language is going to be satisfied. That's why what I will do, I will take s tends to a s1. Now this s1 variable is used to generate a grammar which creates n number of a's and n number of b's, and this a variable is used to add some additional a's, some additional a's. Now s1 is used to generate n number of a's and n number of b's. Now a is used to add the additional a's. Now to make m number of a's greater than number of b's, how many a's, minimum number of a's we should add? At least one a should add. That's why I have given the terminating condition for this a variable as this 1a. Means you should add at least one additional a to make number of a's greater than number of b's, and you can add any number of a's. That's why I have written this rule as like this: a tends to a small a capital A or small a. Means either at least one a you should have, or you can add any number of a's. Okay, this is the complete grammar for this particular language, a raised to m, b raised to n. Understood now how to write a grammar for particular language. Now the next language is specified here, that is the language is given by a string w, Now in this W string, what they are specifying is that number of A's should be equal to number of B's. Number of A's should be equal to number of B's. Now, if you take the first condition, first language, that is A raised to n, B raised to n. Here also number of A's are equal to number of B's. But in every string, the B is going to follow A. You have in every string of that language, the B is going to follow A. Now you have taken this grammar. S tends to A S B. Now in this case, the B is following A. But there may be strings like this. B A. Here A is following B. Okay, these strings will not be accepted by that particular language. Now to solve that problem, what we are going to do, we are going to write another production rule here. S tends to ASB, which is going to generate same number of A's and B's, and it is going to have B following A. In this type of strings, B is going to follow A. Then I have added one more production rule here. S tends to PSA. Here also it is going to generate same number of A's and B's, but in this case the A is going to follow B. A is going to follow B. Now if you write only this much of only these two rules, then it is capable of generating the strings like this: AB, BA, AB, BA. But this language also includes this epsilon. Epsilon is nothing but a null. Hence, we should add this one more rule, that is S tends to epsilon. But there is one more string which can be generated by this language is ABBA. ABBA means here A is in first two characters, B is following A, and in second character A is following B. Second group of characters. You just divide these four characters into two groups. The first two characters is one group, next two characters is another group. In first group, B is following A, and in second group, A is following B. Means it is combination of first two rules. It is combination of first two rules. Hence, to support this type of strings, what we should do, we should provide an option to combine these two. We should provide an option to combine these two production rules. Now how we can combine these two production rules? Just by replacing S to double S. S to double S, where one S can be replaced with AB and one more S can be replaced with B. Okay, this is how we can combine these two rules into a single one by making a production rule S tends to double S. Okay, these are the now in this grammar, how many rules we have? Production rules, 4 production rules. S tends to ASB, S tends to BSA, S tends to SS, and S tends to epsilon. These are the 4 rules which are going to generate a grammar which is capable of accepting all the strings where number of A's are equal to number of B's. Okay, this is the 6th example. Now the 7th example is it is based on a palindrome. Now here there are two different languages are given. WWR, which indicates even palindrome, means this language is going to generate strings which are made up of A and B, and it is going to have even number of characters, and those strings are palindrome strings. It is going to have even number of characters, and those strings are going to be palindrome. Now to generate a grammar for this type of language, let us take a starting symbol S. Now for every A, it should have another A, so that when you reverse the string, you should get that particular character. That's why I have written here S tends to ASA. AS tends to ASA. Similarly, you should, for every B, you should have a corresponding B, because when you reverse it, you should have that particular character at that particular position. Hence, S tends to ASA, S tends to BSB, and S tends to epsilon. Now, this epsilon, S tends to epsilon, makes this language as even palindrome. It is because for every S, if you generate one A, corresponding A is going to be generated. Means if you try to generate one A, no, it is going to generate one more A. Means it makes number of A's as even. Similarly, if you try to generate one B, it will generate another B. Means it is going to generate even number of B's, so that the number of characters which are generated in this language are going to be even. And if you don't want to break that chain, you are going to add S tends to epsilon. Means the number of characters will be remain even. Okay. Instead of this epsilon, if we add another character, either A or B, either A or B, then it will be all odd palindrome. Now this is the second grammar, which is called as odd palindrome grammar, where it is going to generate the all palindrome strings made up of A and B's, but the number of characters are going to be odd. Either the odd character will be A or B. This is how you can generate the grammar for even palindrome and odd palindrome. And this language, what they have given, this language is given specified by this statement WWR union W of A plus B WR. Means you need to perform a union operation on these two grammars WWR and W of A plus B WR, that is even palindrome and odd palindrome. You should perform a union operation. Now if you perform union operation, this will be the result. From this you have taken these three rules, ASA, BSB, epsilon, and from this you have taken only these two, because these two are already present. S tends to A, S tends to B. Now what this language is going to do, it is going to contain all the palindrome strings with even palindrome as well as odd palindrome. Now that last example we have discussed was about A raised to m, B raised to n, C raised to n. Now this is also again same with the first one. You have m number of A's and B's. Only additional thing, you need to add n number of C's such that C is greater than or equal to 0. Means this is optional. You can have 0 number of C's also, or you can have any number of C's also. Now for this, you just again take a help of first language grammar. S1 tends to AS1B slash epsilon. This is used to generate m number of A's and m number of B's. Now what is your grammar? S tends to m number of A's and m number of B's followed by a variable C. Now this C is used to generate the character C's, n number of C's. Now C tends to small c capital key, small c capital C slash epsilon. Why this epsilon? Why you are using epsilon? Because n is greater than or equal to 0. Means you could have 0 occurrences of this. Hence I have taken an epsilon here. If I made this statement as n is greater than or equal to 1, means you should have minimum 1 C. That will be the terminating condition for this C. That's why in that case I am going to replace this epsilon with C, because you should have at least 1 C. But here they have specified that n is greater than or equal to 0, means number of C's may be 0. So that I have given here epsilon. Okay, this is a grammar for this particular language. Now, still any doubts in these grammars? How to generate the grammars? Yes. If you have any doubts, you can ask.
Last time, why taken two times C?
Here, because if I if I take only one C here, C tends to small c, then it is possible to add only one C. You can't add one more C, because C tends to, if I write like this, C tends to C, capital C tends to C, then only once you can replace a capital C with a small c. But in this case, you have replaced C tends to C and capital C. Again, this capital C can be replaced with any number of C's. That's why we have taken here C two times. One is small c and capital C. Now this capital C can be replaced again with CC. Then once you have got n number of C's, then you can replace C with epsilon to stop the chain. This is the reason why we have taken here two C's. Understood? Yes?
Yes, sir.
Okay. Still any doubts from other students? Yes? No doubts?
No doubt, sir.
Okay. Then